Okay, good evening, everyone. It's good to have you with us today again for our second part um, of our Saturday hour programming tutorials. So, if you feel like you need to understand more about R programming, do note down some questions that you might have during this tutorial or after it, and always jump in on Wednesday. There's going to be another R programming tutorial that will be also taking place, and then ask your questions in there. That's if you don't want to wait for next week Saturday for another part of our programming tutorial. So there are two tutorials of our programming that are taking place each week, one on Saturday and the other one on Wednesday. And they'll be taking place around the same time, which is 6 p.m. GMT. And if you like you need to expand your programming skill set, feel free to always jump into our Sunday's Python programming tutorial. There's going to be another tutor that will be taking you guys for Python programming. So if you can have both um, programming skills, language programming skills, I think it will be advantageous to you so that you can at least be able to be versatile when it comes to whichever programming tool that gets to be presented to you, be able to understand and read and work collaboratively with other people in that language, and you won't find it difficult to deal with it. So yeah, I think that's about it. So moving on to today's tutorial, I believe we're just gonna go through at least a little bit of a recap of what we covered earlier on. The first thing that we went through was our functions, right? So after going through with you guys the whole tour around our R console, in fact, our R Studio, right? And I said earlier on that you can either access it online or you can download it online and have a desktop version of it. The advantages of it, I've actually mentioned that online you're most probably going to be using a free account. So a free account is usually going to be limited when it comes to the RAM. So if you ever to analyze a big data set, you're probably going to run out of that RAM that's been assigned to a free account, and might run maybe into some errors trying to analyze large data sets. But whenever you're using your if you're using your desktop version, you might probably not have to run into any errors, since it will be making use of your computer's RAM. So those are like just some advantages and disadvantages of using either an online or a desktop version of the R Studio. However, whichever you decide to use, either an online R Studio or the desktop version, when you sign up online, you're gonna end up on this dashboard. Yeah, and the same thing that you're also going to be ending up on whenever you're using your desktop version. So it's not going to be different much. It's going to be the same. Whatever you're looking at is what you'll be also looking at with your desktop version. And the installation process for the desktop version is just as easy as installing another application or software on your computer. You just have to read through whatever they'll be just asking you, but it's all basic stuff like where should you install it? Do you want to have like a desktop shortcut of it? Just some normal random question that will just be popping up that you usually get to see whenever you are carrying out a similar software installation on your computer. So there's nothing much hard about it. But if you ever run into any difficulties trying to install it, just give a shout out in our group and we'll try to look into your issue, and maybe one of our tutors will maybe get in contact with you and see how best they can help you out installing um, your your R um, your R software, programming software. Yeah. So moving on to, yeah, after we talked about this, after we took such a tour around R, they moved on and started our first basic stuff that you guys need to know, which were the functions. And we said anything that starts, it doesn't need to start with any, but anything that is parenthesis on it, or init is basically a function. So print is a parenthesis in it, and it's basically like, so a function is like, it's like a code that has been assigned within it, or that carries within it a very long line of code that someone had to type and say, if I need to print something, at least I can just call upon the name print with some parentheses within it, and it will print whatever I get to put inside it. So someone's like, I'm not going to keep on writing this line of code over and over again, but we can have it packaged into something, and then we call upon that name and put on whatever we need it to print, and then it will print it for us. So whenever you type print, there's like a background code that's going to be ran within R that you just guys don't get to see. And as I did mention earlier on, or in our first tutorial, that you have actually learned how to create your own functions when you were doing the Stanford certificate for our programming course. So I'm quite sure you've actually went through this one, but we're also going to do that later on. But for the meantime, you don't need to learn how to create your own functions. We're gonna do that for you later on. We're gonna teach you how to do it later on. But right now we just need you to understand that that's what a function is. So it's like a, a huge package of code, line of codes within it that's just gonna perform a certain function for you. That is probably linked to the name of it, like print is linked to printing. So you already know that, oh, something's going to be produced for me, like it's going to be printed out to me. So if I were to type print and say coding is the best thing to learn, right? It's going to print that back to me. Coding is the best thing to learn. And even if I were to say print a number, so it's not just printing things in quotation marks, you can also print numbers. 23 is going to do that and print back to me the number 23. So yeah, that's all about so the number function that we make use of, as long as you remember that whatever that is got a name on it, and then parentheses next to it makes it a function. And whenever you don't understand what a certain function does, or someone is giving you a line of code and you just seem to be confused, like, oh, what exactly so does this function actually do? You can just call upon the help function on that function that you can't seem to understand. So if I were to call upon print, then just by typing a question mark, then the name of the function that I need help with, and then just hit enter. It's gonna call upon help and with the name of the function that I need help with, and then I can just go through it and understand what are the things that I can put inside it, or does it do, and stuff like that. But you can always click on help and look at other things that you need to learn, or the documentation of it is also on that click, and it can just take you to a number of things that are kind of addresses, including the documentation and different functions that it has, and the documentation of each and every other function that R makes use of. So whenever you don't understand a certain function, you just call upon the help function on it through typing a question mark and the name of the function, then you go on to the next one. And then we said earlier on that all these functions have been written and saved in a way that R understands. So someone out there decided to, like, okay, let's have print with a small letter P, right? And if anyone tries to type print with a capital letter P, they'll probably run into an error. So for instance, if I were to do that again, and then type inside it, coding is the best, right? I'm probably going to run into an error, and it will tell me that it can't seem to find the function print within, because it understands that I've placed parentheses in it, and then there's a name next to it, so it considers that to be a function, right? But it can't seem to find it because your print doesn't get to use a capital letter P, it makes use of a small letter P. But if I were to use view, and then I type a question mark on it, because I need to view something, but I don't have anything to view yet. Just put a question mark here, then I call upon it. It's gonna invoke the help function, looking more at view and what it does and so on. So view gets to make use of a capital letter V. So if I were to do that with a small letter V, I wasn't gonna get help from it. So nothing was going to happen because view is actually not considered to be a proper function that R has in its library. So you need to understand that these are very case sensitive. So just make sure that whenever you are typing any of the names of these functions, you type them as they are served or as they can be understood within R. Then after we looked at all this, we then decided to look more into variables, and we said variables are actually considered to be objects by R. So whenever you see an error that gets to be sent back to you and it says we can't seem to find this object, they're just trying to tell you that we can't seem to find that variable. And variables are the one that we use when we want to save certain values and then get to make use of them later on. So if I were to say A to be assigned a value of 10, right? And then I press enter, you can see what's going to happen on my environmental pan. I'm going to get A being a variable that's going to be assigned a value of 10. So this gets to kick off. Then you get to see what your variables are and what their values are. So if I were to say B, right, and then press enter, B has not been assigned any values. I'm probably going to get an object error. I'm being told that the error is that object B is not found because B doesn't have a parenthesis and so it will be considered as a function. So I'm going to look at it and be like, okay, so what is B within R? And then R looks within its database and finds, okay, we have nothing that's going to be, and right now it can only be an object, but that object hasn't been given any value. So we send back this error and say, we can't seem to find that object. And I'm assuming that you wanted to give it a value, but you did not. So if I were to do that and then give B a value and say, this is 15, right? Then I press enter and then I call upon B again. I get the value that B is 15 instead of getting an error that we can't seem to find that object. So this is what we refer to as our variables. So whenever you are writing your variables, always make sure that at least they do not start with a number. They may contain a number within it, but they do not need to start with a number, right? Because we probably run into an error. It's one of the syntax of our programming language or the rules of our programming language. So you can't start with a number. Let's say one sample and then press enter. I would run into an error telling me that an unexpected input has been found. So you started with a 1 instead of at least having a 1 within it. So if I would say sample and then press 1 and then assign it a value of 10 and then do that, I will get my variable sample-1 being assigned a value of 10. Right. So you need to understand, these are some of the basic things that you need to understand. You can have a number within your variable, but it doesn't need to be a number that starts whenever you're naming your variable. So yeah, that's one thing that you need to understand. And whenever you are creating your variables, they need to be assigned to something. And for instance, here, I've been using the assignment operator all along. You can see B, I used the assignment operator and they had it assigned a value of 15, the same that I did for A, and had it a value of 10. So whenever you're assigning variables to certain values, always make use of the assignment operator. This is what we use whenever we want to assign, so that next time whenever we want to make use of those values, we don't actually need to type 10, 15, and so on. We just need to type the name of that value and then makes use of it. So they actually considered to be used, variables that should consider to be used to save our values. So always keep that in mind. I thought, you might need to know one or two things in that area. And then we had to talk about comments, right? And we said a comment can only be made if you type first a hash, then whatever you need to comment, right? So all along, if you were to type maybe just a letter back, right? Just a letter without the hash face, would get an error like I did for B, right? I got an error telling me that you can't seem to find an object with the name B. But if I were to do again and put a B, right, and press enter, nothing would happen. Why? Because the comment is actually being read by R, not as a code, but something that you just need people to know of. So I'm just commenting out that whole line and saying, don't read it, right? But just go, skip it. You can print it, but don't consider it as a code. So a hash, like, it just comments out. It removes that idea that it's a code that Ara needs to run. And Ara will look at it and be like, oh, there's a hash, so that means we can't actually run this one. It's not being considered as a code. Let's move on and go on to the next one, to the next line of code, right? So we make use of our hash when we need to explain our code, right? If you are to type something below it, for instance, if I'm to say a plus operator is used for addition, right? And then I do that, and then below it, I write a code that says a plus b, right? And then we press enter, and you see that it will produce 25 because a is 10 here and b is 15. And if you are to add the two, we get 25. This is where the saving of our values into the following variables becomes a gift to us, right? We don't need to write numbers anymore, just need to call upon those variables that we have saved that holds the following values, 10 and 15, then makes use of that, and we get these values. So if you are to maybe have a huge line of code and you want to keep on typing it over and over again, we can just save them or assign that whole line of code to a variable so that next time we want to make use of that huge line of code, we can just call upon the variable instead, and then it will run whatever that line of code that we have saved it runs. So yeah, always make use of or put it within your habit to save your codes or some very complicating math that you have done, or you want to save maybe a value. Always make use of your variables to save all that, to can just capture all that work for you, and then call upon just their variables or their objects later on in your code. And then we're to move on and talk about different data types, or we're about to talk about data types. So yeah, I believe that's where we ended. And then we're to move on and talk about data types. And we said, we have to address it now. So data types are the different types of data that you're going to be working with, right? So Ara gets to accept a number of different data types, and some of them I think we've covered them in our first tutorial, and we talked about characters, right? I'm just gonna put a hash and say characters. Okay, let's just clean this one up and talk about um, data types. Data types, right? So for the different types of data, the first one that we have, I'm just gonna say number one, we have characters. Characters can also be called strings, and these ones you can see them with the following quotation marks within them, right? So characters can also be called strings. So if in Python, they might usually refer to it as strings. They don't usually call them characters, but here in R, we actually refer to them as characters. They actually mean the same thing. So if you have data that is strings in it, it might be you want to type something, maybe the world is the best, and so on. So I'm just gonna have to go, right, let's just come down, then have it, let's say Karan. Yeah, so that makes sense for you guys. Short for characters. So Karan, short for characters. And then I put these strings and saying coding is the best, right? So whatever I've tabbed within here, within these opening and closing quotation marks, right, is what will be assigned to this variable Karam, right? So I can't use an equal sign here. I have to use this one. I'm sorry, I'm used to Python programming where we make use of equal sign. Yeah, so I have to use this one to say I've assigned the following value. Coding is the best. The following string or character value to the variable chara, which is chara short for characters, right? So if I press enter, this one will be saved here as that. So chara has been assigned the following. So you see the quotation marks are still there. And we're gonna look at how you know the type of data that you're actually using or working with. We're going to cover that one later on. Another data type that might work with is the numericals. So numericals can be divided into two, right? Be divided into, so hash number 2, we have numericals. So numericals, we have double and we have integers. So when you talk of double, these are decimal numbers. When you talk of integers, we're talking of whole numbers, right? But how you type them in R is different from how you type them in Python, right? So you have to understand that whenever you're dealing with a double, so let's say double, just going to use this small one, then assign it to 12.5. So double represents decimals, and then integers, if you want to have a whole number, so inter, that's what I'm going to call it, or integer. I just call it inter because there's no function by that name. And then I'm going to use 10. Okay, I'm not sure where I left off, but just to run down through the following stuff that I've tried to cover before I lost connection to you guys. So I told of the second part that we had to look at, which is kind of what you're looking at in this tutorial here, the data types. And we said there are a number of data types that you're going to be working with and that Ara understands. So the first one that we had to look at is the characters, which are also known as the strings in Python programming, but in R refer to them as characters. So characters, they make use of these quotation marks, right? So whenever you see quotation marks, just know that you're dealing with strings, you're dealing with characters. So whatever is covered with these quotation marks, or that is within the quotation marks, it will be read as a string by R or by Python, right? And then we move on and talk about numericals. So numericals are divided into two, and we say the double and integers. And doubles represents decimal numbers and integers represents whole numbers. And they said if you have a double, 12.5, like I said, decimals, so what represents a double. And if you are to write an integer represents whole numbers. And R will understand that this is an integer if it has a capital letter behind it. If it doesn't have a capital letter behind it, you just read it as a double. So just know the difference, right? So if you think that you're working with an integer and don't put an L on it, I was going to read that as a double instead of as an integer. And if there are implications of doing that, you probably run into them. So that's why we said earlier on in our first tutorial that you need to understand the syntax of our programming, of different programming languages, so that you understand which syntax or which code, which words, which symbols you have to use for each programming language, because they tend to be different for the different programming languages that we have, right? So if I press enter on this one, guess what? Double gets to be assigned the value 12.5 and integer gets to be assigned the value 23L. Now, another type of data type that you might work with are the logicals. So you might deal with the logicals. These ones will produce either a true or a false statement. I'm sorry, I might have forgotten to say 3 here, and then call it logicals, right? So logicals are actually referred to as booleans in Python programming, but here in R refer to them as logicals. So what are these ones? These are true, false, or true. Sorry, I had to type 2 of those. So false is its own, and then true capital letter T and F capital letter F, right? So these are some of the or one of the data types that I might work with. So you can work with booleans that basically be maybe evaluating whatever you have written, then checking if it's true or false, right? Or you might have to deal with numbers, you might have to deal with selection of your data type. They're just running through your data and be like, oh, you need to get things that matches to this. So if it's true, we get to take it. If it's false, we don't get to consider it. We're going to look into that, especially when dealing with the loops. Loops are the ones that are actually amazing at considering true or false statements. So yeah, we're going to be working with that. And we said earlier on, you need to understand the syntax of R. So whenever you're using these booleans, understand that if you are to type a small letter true, you might get a correction, right? But if you are to type just a small letter T and then send it, you get the following error, right? And if I do the same thing for F, I also get another one. And so you need to understand how these booleans or these logicals are actually understood by R. And then after, so you've understood this one, and then we have to move on and understand another last type of the data type that you can actually get to deal with, or that R understands, which is the date and the date time, right? You might be given data that is got date or date and date time within it, or in a certain column. You might need to understand how does R read date and date time, because in most cases you might get that date and date time written maybe as numbers or maybe written as strings, and the arrow just be looking at it and just considering it maybe these are integers instead of reading it as a date, or it might be given as strings and they just look at it and be like, oh, these are strings, instead of looking at it as a date, as a data type that you are dealing with. So you need to understand how R reads date. So in order to do that, like I've kind of introduced you earlier on to packages of R, there's a package that actually deals with date and date time, which is the LubriDate package. But this LubriDate package is not easily going to be called upon and make use of, because it's part of another package that we currently do not have, which is the tidyverse package. Mind you, the tidyverse package is one of the most powerful, amazing data analysis package that you can actually install and make use of when you're in R. So it helps with a lot of data analysis processes, right? So if you need to do your data cleaning, your data engineering, you're doing with feature engineering, when you need to do your visualization, when you need to produce all this different stuff, right? Just know that tidyverse is a certain package for you that can perform a certain function for you. So always have tidyverse installed within your console, so you can just make use of the different tools that it gets to offer you. So for right now, it holds one of the most powerful packages when it comes to data that works with the data, which is the LubriDate package. So I needed to understand how R reads data. So I'm just gonna call upon, just gonna install it first, right? So install.packages. Right. So if I go install.packages and then I put tidyverse within it, tidyverse. So this is like the normal process. Whenever you need to install a new package, you have to type that one out and then press enter, and then it's gonna load that data into R. And then once it is done that, the next thing that we're probably going to need when it is finished downloading this is to open that package and start using it. Yeah, so it's just going to take a little time, but yeah, it should take the same amount of time on your desktop version. So don't be troubled much about it. So all these things that have been installed are the different packages that tidyverse gets to carry within it, right? So we're just getting some extra packages that we can make use of. And one of those packages is the LubriDate packages that we need to understand how R reads our data. So I'm just going to wait for it to finish up this one. Oh, there's the LubriDate package. I think you can see it here. So we're just going to need that one to play around with our data, that dates and date time data type. So this, and then we've got the ggplot2 with the Google Drive. So all these packages, they can do you a lot of help, right? They can help you out with a lot of stuff. Just need to know what each package does so you can make use of its use. in your data analysis. So now that this is done, I'm just gonna save this one. So another thing that I should do is call upon library. So library is the next function that we call upon after installing our package, to just say open up the package for us when I make use of it. So tidyverse is the package that we've installed. We need it to be opened up so we can make use of it. So tidyverse, and see all these packages that tidyverse has within it, which is the dplyr, the forecast, the gplot, and so on. So all these have already been installed now, and we have opened. They are now available for us to make use of them. So Lubridate here being one of the packages that I need to deal with. Just gonna call upon it since I already have it, has been installed for me. I'm just gonna call upon it and say, can I make use of the Lubridate package? Lubridate, there we go. And then if I get to be sent on the next line of code, that means I didn't make any error. So Ara kind of understood what exactly I asked it to do. So now it understands, it just sends the next line of code and there were no errors sent to me. If there were any errors, I would have to look at what I could have done or what did I do which was wrong in there. So now that we've got our Lubridate package ready for use, I'm just gonna call upon as date, and guess what? This thing gets to show up. Amazing, right? So it gets to tell you, and you can see here that it's coming from Lubridate. So this is coming from Lubridate, and is another one else? No, these are the only two that is coming from Lubridate currently. So I can actually make use of these functions, and they're saved within the Lubridate package. So I'm just going to say date time. So I can have only the date. If I need date associated with the time, I can then just click on date time. Then within it, there's a function called now that I can actually make use of. So I'm going to call as datetime and say I need date and time together, but of when, then I'm just telling it I need it of now. So if I press enter, it's just to tell me that right now, where I am, it's actually the 28th of May, 2025. And my time is 28 past 8, 41 seconds. And this time is being read in UTC, which is the universal coordinated time, universal time coordinated, yeah, something like that, I hope. So yeah, this is how R reads date. So if you just give it date that is only in string format, it's just gonna look at it and be like, okay, so I have a string that I need to work with, but you might need to tell or to change that string into the date or a date time that Ara can actually understand. So this is just giving an idea of how Ara deals or understands date as type of the different data types that you are gonna be working with. And then before I go on further and talk about structures, right? I'm just gonna move on and talk about pipes before I jump into structures. So a pipe is a tool for expressing a sequence of multiple operations or represented with actually let's just type this one out so you guys can see this symbol with a greater sign and another symbol. So yeah, so a sequence of multiple operations represented with that sign. And what exactly does it do? So it's just represent it. So it's just showing you that I'm moving from one operation to another, one operation to another, one operation to another. Then I'm gonna give you an example later on of where you can actually make use of this, but I just want you to know that it's that tool that can be used to apply the output of one function to another. So if you've got an output from one function, then you just want to use it into another function, you can have this one in the middle and it will help you or to navigate or streamline that process for you. So it's like a pipe that connects two different functions, like from point A to point B. Like we're moving with our data from data cleaning to data sorting, and then from data sorting to feature engineering, from feature engineering to visualization, from visualization and machine learning, and so on and so on and so on. So it's like eating in the middle. It's like a pipe that's connecting all these operations together. I'm not going to cover it now, but we're going to look at it later on. So I just wanted you to be aware that we can make use of such a tool that takes in the output of one function and then puts it in as an input to another function. So yeah, we're going to look at it later on. Just keep in mind that we have such a powerful tool. Now we have to move on and talk about data structures, right? So when you talk of a structure of something, we want to understand like, oh, this is a house structure. This is like the structure of a house. If we're not looking at a plan, a blueprint of the house, we're gonna see different, like, okay, so this is how the house is gonna come out like. This is like the structure of the house, right? Then we're looking at it from a physical perspective. We're looking at the house, we're looking at it from a distance to be like, oh, so this is like the structure of the house. This is what says this is a house. This is what makes the house, and so on. So whenever you do dealing with data in R, right, you're gonna organize it and store your data in different structures, right? You can store it in as vectors, install it in as data frames, install it in and access it as matrices, or you install it in as an array. So these are also like the structures that you can work with your data, or how you can store it, or how you can organize your data and then be able to read from it. So once you've chosen whatever structure you need to understand how to apply certain methodologies to it. So structures can help you maybe to view your data or maybe to work with your data, right? Most people consider dealing with vectors, right? Whenever they're doing a lot of calculations or complex calculations, be like, vectors, I think they're easy to work around with, and they can actually help you to reduce your uh, the number of items or data points that you're dealing with. So vectors can actually help you to narrow it down. Some people can say, maybe I'm used to working with the data frame. Therefore, we're going to look at all these data structures um, yeah, as we talk, but some people can just be like, I want to deal with the data frame, right? The data frame is like you're having your data being presented to you in an Excel format, right? You have your rows and your columns, and that's what um, data frames be looking like for you. And that is maybe like, I need to work with my data or have data that's stored as or in matrices, and others can be, I need to have it as stored in an array and things like that. So it's different structures, it's different ways that you store your data that someone can actually understand and make use of it. So these are some of the different data structures. So we're going to look at the first one, which is the vectors. The vectors, they're kind of divided into two with the atomic vectors and versus lists. So when you're dealing with an atomic vector, these are like the primary types of vectors. They are one-dimensional and they make use of only one type of a data type that it gets to deal with. So as a structure, right, a data structure vectors, they only deal with one type of a data type. We've talked about different data types, right? We looked at characters, we looked at booleans, we looked at numericals, we looked at what is left in this one? Dates and date times, right? I'm just saying, if you're going to create a vector, right? So let's do that. Let's create a vector. I'll call it vec, right? And say vec here is going to be assigned the following vector. So how you create a vector, you start with a C, and then it must have parentheses next to it. And then if you put in any item within it, always make sure that there is a comma. That's how R is going to know that you're dealing with a vector. I think the same thing applies to Python programming. If it doesn't find an R, it might consider it as something else, maybe a set or a list. So you need to make sure that there is a comma next to it so that R can read it and consider it to be a vector. But this is basically how you create a vector. So a C, open parentheses, then put whatever you want to put inside, and then divide whatever data that you have inside with a comma. So if I say 1, 4, 6, 7, right? Then I press enter. There's a vector that's going to be created here in my environmental pen, and it is the following things: 1, 4, 6, and 7, right? So if I'm to say vacuum, and then I use the following extraction, when I look at it later on, the extraction operator that we have, so it's is the opening and closing of these square brackets, right? And then I say 2. So when you're dealing with indexing, so what I've done is called indexing, right? You will also apply the same thing in Python, but the difference is Python starts with a 0 index, while lists R starts with a 1 index, right? So the saying in 0 is that it's going to read the first value as on 0 position. That's in Python, right? And then consider the second value to be the first position, so 1 assigned to it. Then the third value be assigned a second position, right? Instead of being assigned 3. But when it comes to R assigns it as they are. It starts on 1, right? So the first value or the first value will be 1. And it will know if I say 2, I need the second one. If I say 3, I need the third one. If I say 4, I need the fourth one, right? That's why I've been told here that with 1, 4, 6, 7, and they're ranging from 1 to 4. So the dot dots represents how far we are moving. So 1 to 4. And yeah, so I have, if I were to say vec2, right, extract or index 2, I needed to find 4 for me. So if I press enter, I get the value 4 assigned to me. So the first values, like they are written here, let me just do another one on top. I'm gonna do vec, then say 2, 2, 5. 2, 2, I won't do that for me. So 2, 3, that's 1, 2, 3, 4. I'm going to choose 4 here. Right. So it's going to skip 1 and then take 4, 6, and 7 and return it back to me. So 4, 6, and 7, they get to be returned back to me. What I want you to know is that these ones, the first things that I've written here before the comma, they are the rows, right? So whatever you write before the comma is going to be considered as a row. But we also have columns, right, that are going here. So if we're looking at this vector, it is maybe 1, 4, 1 by 1, 2, 3, 4. That's if you're mostly dealing with matrices. But the first one, if you're dealing with vectors, right, this is how you look at it from. You need to consider that the first one before a comma, they are the rows. Then this first one before, after a comma is considered to be a column. Right, so we're going to look at it later on. Don't worry about it. We're going to look at it, but I just wanted you to know that anything before a comma is considered the rows. So you'll be assigning, you'll be looking for values along the rows. And then after the comma is looking for values along the columns. Okay, so that's how you create a vector, right? And the same thing, like I said earlier on, this one, they only include, the must contain only one type. So you can't mix different data types. Like what I've done, I have, since I don't have an L on the back, capital letter L, these are going to be read as, type of, can be read as doubles, which are referred to as decimals, right? So if there's a type of vec, gonna tell me that that is a double, right? So it's considering this one to be a decimal collection of numbers, right? So if I were to take a different number, right, I just want you to see when I talk of that they can't have different types of, okay, there we go. I'm just gonna change this one and give it an L, right? So I have a mixture of numbers. Like I said earlier, we can't have a mixture of numbers. Let's see what this one is going to be converted to or as. I'm going to say type of now again. Oh, actually, I think I don't need to do that. Just do this type of vacuum, right? It's going to tell me that it's still a double, right? Although there's an integer in it. So it's considering everything in there to be doubles, right? Including this integer number in here. So if I were to use the extraction operator on 6, which is 1, 2, 3, right? So it's the third number. I press enter, right? I get 6. Great. So I want to ask it what is the type of, I want to ask it type of vacuum. And then I'm going to say 6. When I see if you do the same and tell me that it's an integer, right? And then here's the answer. It's being considered as a double, right? So everything in here has been turned into a double. Let's say we have changed this one instead of having an L, we decided to have a T in it. So a T represents a different type of data type, which is the booleans, right? I'm going to press enter. Then I'm going to do the same thing. I'm going to ask it to tell me the type of 6, right? Let's just start with type of vector first, right? It's telling us that it's still a double, although there's a T in it, right? So everything in there is being read as a double, including the T itself. So that's what happens when you decide to have different data types within a vector, right? It's going to be turned all of it into a certain data type that it understands. So including the T is going to be considered as a data. It's not going to be read as just the type of 6. So I'm going to choose 6 here because we don't find 6. I'm just going to choose 3. Say vacate 1, 2, 3, and you'd find 3 for me and tell me what it is. Then you'll be telling me that T is not being read as a boolean, but it's actually being read as a double. So it's actually a number with a comma, but we actually can't seem to see it. That's how vectors play around with a different number. So always make sure whenever doing the vectors, you understand that they make use of one data type, right? They can't have different data types within it. So that's one thing you also need to know. And I clean that one up. The same thing I think we've mentioned about integers, and I said, let's just call this one and see the type of int, right? Type of int. I'm just gonna do that. Type of int. So don't get confused. Int is a variable that we have saved earlier on, this one, to have a value of 23L. So if I do that, it's going to tell me that int is an integer, right? So it is saved it with the name so that it becomes easy for us to know. If I do type of again and then choose Kara, right, to tell me that Kara is being read as a character, the value that's within R, that's within Kara is a character. This is the value that we're looking at. And if I do the same thing for, what do I have? Do I have a one number, integer I've done, double I've done? I didn't save for booleans or dates. So I'm gonna need to work with that. Let's try it. Type of, so let's try with the date first, right? I'm just open this one and send me an error is date, right? Now do this, I'm gonna put now inside it. So what is gonna read, remember, that one we have this. So as date, and then we have now within date, yeah. That thing that we produced earlier on, yep, that's the one. The date that we looked at that showed us our current day is our current is my current time. So it's our current day, but my current time. That string that we looked at earlier on, yeah, right? When I called is date now. That's what's basically is in here. So I want to ask you, when you look at that, what do you see? What is it exactly? I want to press enter and tell me that it's a double, right? So it can't seem to understand what date or what I'd given it is exactly, because there are numbers in it, right? And the numbers didn't get much um what is it? Didn't get much of what it represents, right? It was just a whole line of numbers. And looked at it was like, okay, so I'm looking at numbers. They basically just represents what? They basically represents um doubles to me, but they don't have an L in it, but they look like numbers, right? So they represent doubles to me. So that's one thing that you look at. So we're going to look at date and then make sure that it understands that we're never dealing with this one, we're dealing with date, right? We're not dealing with the doubles, we're dealing with that. So that's something that you need to understand whenever you're having numbers and dealing with your data. The last one that I haven't used here is, let's just try this one, which is a boolean in F. But to call and ask you what is this, it returns that this one represents a logical, right? Then the same thing if I use true, we read that one as a logical. So you don't get booleans. Booleans, you get them in R, in Python programming, but here we refer to them as logicals. So we have covered the different data that we have, and instead of using type of, you can even ask it. It makes sense to say is dot an integer. What are we considering to be an integer? Inter, right? So I have inter. Did I say inter? Yes, I did. So inter is this one 23. Want to know? So this one, whenever we make use of it, is gonna send back to us. We're asking it a question: is it an integer? The following variable that we've placed within your parenthesis, right? And it's gonna look up and check if it is an integer, yes or no. So if it's a yes, it will bring back to us true. If it is a no, to bring back to us false. Like I said earlier on, that's where Booleans gets to be used whenever they're evaluating statements, right? So this one will tell us is dot integer. Maybe I've typed this one the wrong way. Like I said earlier on, you need to make sure that you understand how these things are actually saved in R. So R can understand what it is you're asking you to do. It can look for that function and be able to run it. So if it is an extra R it's not going to run, it's going to say, well, I can't seem to find the function that you have given me, and it's not making sense to me, right? So you need to always look out for that one. So the press enter key, I will just get through here. Yeah, just telling us if it is an integer. If I do the same thing and I use character, right? So character, if I ask it, is integer a character, right? It's going to look up and see if this value represents a character. It's going to send it as say false. It's not, because a character needs to be having quotation marks in it. Like Kara has got a value with quotation marks in it. So if I do that one and I ask it, is it a character, to send back to me true? Yes, it is a character. So you might remove character and put double and put um, logical and put character and put integer and put, and yeah, the ones that I've mentioned here, or even put date for you. Anyway, this brings us to the last part of things that we can actually be concerned with when it comes to vectors. So that's how you check the type of vector that you're dealing with. And now we need to understand, how do you see how big your data set is if it is served as a vector. So a vector might be really, really a continuous set with a lot of numbers in it. You just be wondering, oh, how big is the data set that I'm working with? But your data set has been, or has been, or it is served as a vector. It is, yeah, that's how it has been served. But you might still need to know how big your data is, so you can at least understand, you can at least measure up and weigh in and see if you can use it on this limited RAM, or maybe using a computer for the derivation of R, or maybe you might need to use an online instance or virtual computer to analyze your data set. So how do you check how big your data is before you even start working with it on R, or maybe when you want to work on it on R? So you call upon the function length, right? So I call upon the function length, and then I put dog. Okay, I need a list here. Do I have a list of things? Yeah, Veki. Veki is a list, so I'm just going to use Veki. And I type enter to tell me that I have 4 data or objects in it, right? I have 4 data points within. That's how big vec is. It is 4 data points in it. So that's how you check the length. So the length function is actually used to check how big something is that you need to work with. So whenever you call upon the length function, then you put whatever you need to find the length of it off. It will give you, or look that one up for you. But this time we're just looking at it on vectors. And then you might also need to name a vector. So all along we're not naming vector, just dealing with vectors. So let's say Veki is great. So we're going to use Veki. And then from Veki, we're just going to say call upon the following function again, names. And we're telling you to name each vector in there and give maybe a column, right? and say, so we have up to 4. So the first one is going to be an A. I'll go and say comma. Then I'm going to say, oh no, that one doesn't need to start with that. So we need to have Veki inside and tell you that we're going to name Veki. And then Veki is going to be assigned to the following C value. So just to correlate with the number of values that Veki has. So A, and then when I have B, then when I have C, and then when I have D. So for 4 values, if I do this, if I don't get an error, that means it's actually understood that Veki has been named, right? And then if we've actually done that right, if we are to call upon view, I think I did introduce you guys to this function view, then I put Veki in it, should be able to divide and show me what each value is being assigned to, right? So if it's A, you see that A has been assigned a value double, which is only 1. That's one value that has been assigned to it. B has been assigned to another double, which is 1. Why are they called doubles? Because they don't have an L, these numbers, or Veki, they don't have an L on their back. So they're actually considered doubles. So view kind of views our data set for us, so we can have a quick look at it. Okay, so that's how we go about naming your vector. And then you might also want to maybe extract. I think I've introduced you to the extraction operator, the one that we use to extract different numbers. So if I were to say, let's say Veki, right, and then I say I need 2. So you can just understand we've already actually went through this one. But if you want to extract the second value, right, the second value, like I said, Veki, in Python, indexing starts at 1. It doesn't, in R, indexing starts at 1, but in Python, it starts at 0. So 1, 2, 3, 4 is when we start counting the position of different items that we have. But in Python, they start from 0. So 0, 1, 2, 3, and going. So the 0 being the first item, and then 1 being the second position of the second item, and going on and on and on up until it finishes up. So Veki 2, we're looking for the second position, the second value in that list, right? So if I say Veki 2, I should be getting a B, and the value that is associated with the B is, if I look here, it's 4, right? So that's what it's going to send back to me and say, actually represents B is equal to 4. So the same thing can actually be applied if you want to use the extraction operator, and then you say Veki, right? And I say, I only need the value that is assigned to B, right? Then you tell me that B has been assigned the value of 4. So that's how you go about extracting certain variables. So let's just say maybe you wanted to, let's do that. You wanted to just make use of 2 numbers, right? But you don't want to keep on writing those 2 numbers. So just write 2 here. I want to assign it to the value Veki. So that's how you actually work with getting a chunk of your data. If you not work with all of the data, you will see this one happening, or people are making use of the extraction operator, basically telling you that we're not going through, or we don't want to take all of the data, just want to take a certain part of it. So if I say 2 through 4, right? So I'm going to skip the first number, which is 1, and return to me 4, 1, 7, 4. So that's 2, 3, 4. Right, so if I press enter, to be given the following digits 4, 1, 7. And now my indexing is moved from 1 to 3, which is different from 1 to 4 for Veki. Right. So whenever I want to use those 2 values, the values of 4, 1, 7, I just have to call upon 2. So that's where you can actually comes into play whenever you want a section of your data set. You know, work with the whole data set, just a section or a subset of it. This is what you can use to do that. Okay. And then the versus one. So I clear this one up. So when you're talking about atomic vectors, right? I told you that they only deal with one type of data. If you mix them up, they're going to convert it to one type only, right? But there's what if you want to have different um, data types within your vector, right? So within a vector. So make use of lists, right? List becomes our second thing that we deal with. So clean this one and call up one hash for commenting and say you're talking about lists. So how do lists come into play? How do you create a list? So a list allows you to have different types of data types in it. So you can have, let's say, L. So you create a list. So I'm just gonna name my list something like stuff, right? Then assign it to a variable. This is how you create a list. So you type list in your parentheses, then you put in whatever you want. So I'm gonna have a string in it, so I can have different data types in a list. Then I can have an integer in it. Integer needs to be having an L next to it. Then I can have a decimal in it, 1.5. Then I can also have a boolean in it. And it will remember earlier on, whenever we put different data types within a vector, we were getting it was converted into one, and we were getting only one type of vector being sent back to us, right? So if we do the same thing for stuff and then we assign it all these items inside it, guess what happens? Stuff here to tell you that we have different values, right? So A is being assigned a character value, right? Then we look at 1 is being assigned an integer value, and the num is being assigned a numerical value. So numerical here is actually being considered as a double value. Then true being assigned a logical data type, right? So it's able to tell that we have different data types within it, so we can work with it, right? So it understands that, it reads that, and it accepts that because it's dealing with a list. So a list kind of allows us to do all this. You have different data types that might need to work with. So we can just be limited to one, right? So whenever you're naming a list, you can always make use of, let's just say, name, right? So we give it name and then give it summand operator and say, this is how you name a list. So you call upon your list again. Then you say, I'm gonna choose capital cities that I'm familiar with. So Harare, I think it's for the Zimbabwean country. I'm gonna give it a 1. Then I'm gonna go Cape Town. Cape Town. Oops. Cape Town. Then I'm gonna assign it a value of 2. Then I'm gonna go Abuja. Okay, strings. So I need to have Abuja. Now assign it a value of 3. And then because I managed to watch Money Heist, I know there's Nairobi. And I'm gonna assign it a value of 4. So this is how you assign values in a list, right? So I assign values in a list. So if I were to use my extraction again on these lists, right? For Harare, I should get the value of 1. So let's just try it out and see if it will do that for us. Okay, I love what it is just done for us. So you can see that Harare has been assigned number 1, Cape Town number 2, Abuja number 3, Nairobi number 4. So if I say num, right, and then I say I need Harare, let's choose Abuja. It's easy to type. Right, let's say I need the value of that to be able to tell me that Abuja been considered as a key. So I like what it did here for us. So this is not considered as key. So if you're dealing with a dictionary in Python, this is how key is actually made. So Harare is a key that is the following item 1. So the $sign is kind of representing the key, but in R to be representing a variable that has got the value that. So Abuja is 3. If I were to do the same thing for Cape Town, I'll get 2. For Nairobi, I'll get 4. And then for Harare, I'll probably get 1. In fact, I won't probably, but I will get 1. Then we're to talk about dealing with the date and date time, right? I want to introduce you to how R understands dates and date time, how to read them, how to expect to look at them. So if you happen maybe to get, let's say you are working with your data set and there's a column that has date that has been saved as, I'm just going to say y is equal to, I just put a string here and say 2016 dash 08 dash 22. So I hope this is August. So 22 August 2016, right? So when R looks at this, if I say type of Y, right, then I press enter. It's gonna say that's a character to me. It doesn't represent a date at all, right? But we need to deal with it as a date, not as a character or a string. So how do we change it to a date that R understands and looks at it and be like, okay, so we're basically talking of a date. So what we do is, since I've downloaded and installed a package, Lubridate, right? Lubridate is kind of the one that we use to manipulate different strings whenever we're dealing with the data and when I change them from strings to data or vice versa. So Lubridate is our number one go-to to whenever we want to play around with our dates. So how do we go about it? So we make use of the following function, which is the YMD. Sorry, I just need to go off, so I can just do it again. YMD, and then tells you that this one is coming from the Lubridate. So if you have date that extends, or just date only, you can just have the YMD. If you have date that extends to hours, right? So you have year, month, day, and then you have hours, right? So you make use of this one. Then we have year, month, day, and it extends from hours to minutes to, you make use of that one. And then for the last one, if you have like the one that extends to seconds, like the one that we had for date now, you make use of this one. And then what you get to play around with is the first here, the YMD. YMD has to match what is written in your data, right? So it understands that this is how your date is arranged. So here I've got the year, I have the month, and then I have the day. So my Y, you need to move from the year, the month, to the day, right? That's how it works. So if I do that, then I put a Y here and I say that's how Y is arranged, right? Because this is how it's arranged. So we have the year, so Y, you have the month, M, and I have the D, D, I have the day and D. If I press enter, it's going to change it to a datetime that we understand. I now understand that we are dealing with a datetime. Now I'm just going to name this one and call it maybe C. For C changed, I'm going to assign it to YMD, then put a Y here and see what's going to happen in our environmental pen for the value that we given to char. So I say enter, right? See, char here has been assigned, it's been read now as a date by R because there's a UTC attached to it and saying this is how it's been arranged. Let's say we have decided to have a different arrangement here and have, oh, I have to call up on this first one first. There we go. And then instead of having the year, start with the day, and then we have day, month 06, and then year, we say 1997, right? Then I press enter, and then I'm going to change how my chart is going to be arranged. So the YMD is the one that I need to change now. So instead of starting with the year, I'm now starting with the day. So D gets to be first. So I start with the D, Then what follows next is the month, so I put an M. What follows next is the year, so I put a Y. So DMY is how my date is arranged within Y, right? I press enter, char has been assigned. And now it understands that char reads as 1997-06-20, right? So it's still been arranged differently here when it gets to our environmental pen, but it's the same concept that we get to use. So this is how you change your data from strings to date that Ara understands. So we're moving from strings to data that Ara actually understands. So if you just maybe need to know today's date, you can just call upon today and then you go enter, just say today is this. Then you just say, maybe I need to understand what the date and time is for me. Just call upon now and now will tell you that this is our today's date and this is our time, right? So it's just giving you that quick information for you as well as how things are actually arranged. So it doesn't matter if things are actually arranged in strings, they can actually be arranged in numbers, and someone might need to understand, like, or you might need to tell R that, okay, what I'm working with right now is basically numbers. So you may have a data set that is numbers like this, and you just want it to know that whatever you're looking at is numbers, right? And these numbers represents days. So the same concept that just applies to the day, the first one is the day, the second one here is the month, and then the third one here is the year. So if I do that just by using numbers, it's going to understand that, okay, so the numbers that we have then not just numbers, they represents date. So if I press enter, I see that char still understands that that is a date. I didn't get any error. So that's how R manipulates or deals with dates. Okay, so the last structure, well, I'm not gonna say the last one, but let's talk about a data frame, right? We might also need to cover this one. So data frames are basically, like I mentioned earlier on, that's another data structure that I need to deal with are the data frames and how are data frames actually saved. So data frames, they're actually saved, organized, or stored like how you store your data in Excel. So you're dealing with the rows and columns, right? So for your rows and columns, let's just see how you create that one first. So I'm just gonna go and say now we are dealing with data frame as one of our data structures. So data frame, right? So how do you create a data frame? We talked about how you create a vector, right? Now we're talking about how you create a data frame. So to create a data frame, what you need is to make use of vectors. That we're going to cover vectors first. So they take in vectors as their input. And the following function is really important whenever you want to change a vector into a data frame, that is rows and columns, data that is arranged in rows and columns, and within the parentheses we put a vector in it, and then we assign it. So x is equal to, like I said, it takes in a vector c, and then c can give maybe 1, 2, 3, 4, 4, and then on your y, right, you can have is equal to c, then I'm just gonna put 2, 5, 3, 5, 4, 5, 5, 5. Right. That's how it takes in a value. So I'm just gonna, I need to save this one so that, oh no, no. Oh, dang it. I have to retype that again. Okay, so instead of pressing enter first, I was supposed to have pressed something else first. I was supposed to save it. So let's just do that. So let's call this one my frame, right? Then I'm going to assign it to data dot frame. I'm going to put in the same thing that I placed in. So I said it actually takes in what? A data frame. You might actually change a file that you have uploaded into a data frame. That's the same concept that you actually applied to. Just have to put within the parentheses the file path to the file that you want to turn into a data frame. So it might be a CSV, so just put the file path to your CSV or to an Excel format or whatever that can be changed to a data frame. So one of these one. So now just showing how you can create one, but you can actually upload your data and have it turned into a data frame and start reading it like an Excel document. Let's just do that again. 1, comma 2, comma 3, comma 4. And then for Y, put a comma here and say Y. It's gonna take C again. And then C is gonna have 2, comma 5, comma 3, comma 5, comma 4, comma 5, comma 5, comma 5. So I have 1, 2, 3, 4. I have 1, 2, 3, 4. If I press enter, I have a data frame. So I love what this one is just done for us. So it's just telling us that 1, 2, 3, 4 X values of full numbers 1, 2, 3, 4, and the 4 Y values of the number 2.5, 3.5, and so on. So if I'm to view this data frame, you see the difference between the one that we had earlier on and this one. Save frame, then I press enter, save it for me. Okay, then press enter here. It's gonna open up our script, and then it's going to just arrange that as we wanted. So X is 1, 2, 3, 4, and Y is 2.5, 3.5, 4.5, 5.5. So 1 is represented by 1, 2.5, 2 by 3.5, and so on and so on. So if our data being arranged into rows and columns, right? Where was I? So let's say we want to use the extraction operator just to get a certain value, right? Then we say 2, comma 2, comma 2. So like I said earlier on, right? Anything before a comma is considered as the rows. Anything after a comma is considered as the column. So if I'm to go up here, right, then I pick 2 in R. What's amazing is that index starts at 1. So 1, 2, right? And then that's my row. And then the second one is telling me to go on 2, right? So I'm gonna go here and say 1, 2, right? So where does it meet, right? It meets here, 3.5. So that's the value that I'm going to get. This one is the value that I'm going to 3.5, right? So if I press enter, oh, oops, thought I'd actually use frame here. Just gonna use frame, sorry. Just use, you're actually using Z for my stuff. So if I put frame and I play 2.2, I get a 3.5 value back at me. So that's what you need to understand about indexing using commas. Actually, you can actually use indexing using X, use indexing using so our column names. So I think we have done that earlier on when we had to index using the strings. So that's indexing using the string. But if you want to use indices in the string, you can actually make use of this one. If you want to get a specific value, then you can save it to a certain variable and make use of it later on. But that's how you basically index your values in a data frame, right? I remember that I had to introduce you guys to file creation, right? And I said whenever you want to create a file, you need to use file.create. Whenever you want to use copy a certain file that you're working with, you can actually make use of file.copy. And whenever you want to delete a file, you can actually make use of an unlink function. And all these that I've said are basically functions that you can use to deal with files within your R programming environment. So we're gonna look at that later on, but if you wanna go ahead and look at it, you can always do that. But it's gonna take like so much of our tutorial time to just cover those three. But do not worry about it. We'll look at it later on in one of our tutorials. But for the meantime, just know that you are able to actually create your own files within the R environment, and you can actually copy certain files that you're working with, so you can even duplicate and you don't have to deal with the original copy and keep the original copy safe, and you can manipulate and play around with a copy of it and leave the original copy safe and untouched. So you can always look at it if in case you have terribly mess up your copy. So it's always good to have like a backup copy. That's what we call a backup copy. So your original one becomes a backup copy, and then the copy that you're actually using, you can actually do whatever you want with it, play around with it, and you can destroy it and won't have to worry much about changing the original data in any way. And whenever you're done with it, the way you can only get rid of it is using the unlink. So whatever file that you will have, it will probably be saved here, right? And then when you unlink it, it will be destroyed from this working directory. So always look into that. And the last data structure that we have to look at is the matrices, right? So the matrices, they're really, really, really important whenever you have to work with data that is kind of in two-dimensional, right? So remember when you introduce vectors, we say they were in one-dimensional, with atomic vectors in one-dimensional, but matrices can introduce you to two-dimensional collection of data elements. So you get to have both rows and columns, but the funny part is when considering data types that they can have, they can only act as much as the vectors do act. So they can't have different data types in them. They need to have only one data type in them, right? So they're like brothers when it comes to data types with the vectors. They can only accept one type of vector. So you can't have a mixture of vectors in a matrix. They're gonna be different. So how do you create a matrix? By just calling upon the name matrix, right? And they're also taking vectors inside them, so that's good. So we have matrix, right? It takes in a vector inside it. So we have maybe C is equal to 3 point, oh, what I love matrices, they can just do an arrangement for you. So 3 to 8, right? I want you to create a matrix that starts from 3 and ends at 8. And then you put a comma and say how many rows you want it to have, right? That matrix that you're going to create, how many rows you want it to have, and then you just say row, and row is equal to, maybe you want it to have 2, you want it to have 3, you want it to have 4, whichever you want it to have, but it's gonna match up with the number of the number of the numbers that are going to be in that matrix. I've picked 2. Okay, I think I was forgetting to just call you matrix, or forgetting to assign my values to save, so I don't have to, type this over and over again. So the same matrix. So you see something has been created up for me here. So I've 1 to 2, 1, 3. Let's just view this one so you can see what we want to solve. View. This is where view actually comes into play. So right now, you're basically learning in number function. Now you know what the print function actually does, and you're aware of what the view function actually does, because you're making use of it a lot. So let's just remove that one. Then let's see if something will pop up here. Okay, nothing. I'm just gonna press enter, then ask it to view the data for me. So when it does that, you can see I have 3, 4, I have 3, 4, 5, 6, 7, 8. That's has been arranged in the matrix, right? So you can actually not only consider the number of rows that you can have, but you can also consider to have a number of columns instead of rows, right? So if I come here and I say number of I need you to have 2 number of columns, right? Then I press enter. So matrix has been changed to value. And what I love about it is I have now 2 columns instead of 3 columns that I'd mentioned. I mean, I'd asked it to have 2 rows, so that's why it got a bit longer. Now I've asked it to have 2 columns due to be longitudinally long instead of vertically long, longitudinally long, right? Because I asked it to have 2 columns. So V1, which is column 1, V2, column 2. That's why it's limited here. And then if I say I wanted rows, two rows, press enter again. You can see now that I have only two rows, one, two rows, one and two rows, and then my columns had to be more because of that. So that's about the different data structures that we have. So we have the matrices, we have the vectors, we have the arrays, um, and then yeah, data frames being the last one. We've covered all that. So feel free if you have any questions whatsoever to just throw them into the group. But as far as understanding the basic stuff of R, I think we have covered that. And then the next time we're gonna meet, I'm gonna introduce you guys to different operations that we have in R, right? So the next time that we're meeting up, we're gonna cover some basic calculations in R. We're gonna look at assignment operators, and they're gonna look at, actually we have only one assignment operator, we've already looked at it, so we're gonna skip that one, but you're gonna look at arithmetic operators, the addition, the subtraction, the multiplication, the division. We're gonna look at that and we're gonna cover that with a lot of examples so you get to enjoy it. And then we're gonna show you how to save your scripts, how to always open them up and continue working on them so that you don't lose your data, you don't lose your progress when you're working on something, and then how to close them and yeah, something like that. And then we're gonna look deeper into our operators, our logic operators, how they can be applied when you're dealing with the data set. So I'm also gonna introduce you guys to your first data set, right? In our first tutorial, I introduced you to a demonstration where I just grab a certain random data set from R, and I just had to do that going fast. But right now, we're going to introduce you to our first data set. And we're going to look at it. We're going to open it up, but we're just going to be using the basic stuff, the logic. I suppose when I introduce you guys to where logicals actually get to be used, right? So we talked about logic operators. So after arithmetic operators, we look at logic operators and look at a number of things in our next tutorial. So feel free to jump in and look at it. If you feel like you've been confused by anything that I've explained in this tutorial, there's always a second R programming tutorial that'll be happening on Wednesday. So feel free to throw in your questions in there, and probably me or the tutor that will be taking it will probably help you out either in our WhatsApp group or during that session. And if you feel like you actually need to be in this one, we can always meet again next week, Saturday. Otherwise, it's an amazing good day to you guys. I hope you enjoy the rest of your day. See you next time.